This great question contains some wonderful concepts related to geometry and trigonometry. That's why I wanted to do it and share it with you. Moreover, I thought, I'll solve it in a certain way, but maybe there are people who can solve it much better than I can, and they'll write it in the comments. That's why I decided to do it. Let's get started. Now here we see a square. Of course, I'm thinking about how the fact that it's a square contributes to the question. First of all, for it to have any contribution, I first need to consider this isosceles triangle here. If we drop a perpendicular in the isosceles triangle, from here, the perpendicular I drop will divide the base into two equal parts. So if I call this length 1, then this side will also be 1. Now I can use the square. Since this is a square, meaning all sides are equal, I can also call this side 2. At this point, we can actually cut our connection with the square. In fact, from this point on, you could also split the shape here into 2 and proceed that way. The question was, but I'm not going to do anything like that now. Besides that, we also have another situation. Let's call our height here h. If I were to write down tangent 15 degrees, then tangent 15 degrees precisely equals the mathematical ratio of the height, which we denote as h, to its adjacent neighbor, which is numerically 1, is simply h divided by 1. Now tangent 15. It turned out to be equal to h, so I can write tangent 15 in place of h here. So, if I were to drop a perpendicular line from this point here to the adjacent side of the square, I can then confidently call this particular part tangent 15 degrees. Thus, this part here will be 2 minus tangent 15. Now, I also knew this length. Since this length is equal to this, it will be 1. At this point, I actually have the basic strategy to solve the question. From here, I can find alpha, because tangent 15 has a specific value. So, this part has a certain value, and this part has a certain value. Well then, now I can find alpha. How? I say tangent alpha equals opposite over adjacent, so 2 minus tangent 15 will have a certain value. Then, since they're probably asking me this, I assume the value here allows us to determine the alpha angle here. Now to do this, of course, we need to calculate the value of tangent 15. Let's not just memorize it. Let's draw a right triangle with a 15-degree angle and calculate tangent 15 ourselves. Now, let this be 90 degrees. Let me draw a 15-degree angle here as well, like this. Let this be 15 as well. 90, 15. And here is 75. If I subtract 15 from 75, this makes it 60 here. So I can call this part 30 as well. Now, if I call the side opposite the 90-degree angle 2, then the side opposite the 30-degree angle will be 1. The side opposite the 60-degree angle will be root 3. Since we have a 15-degree isosceles triangle here, if this side is 2, then this side will also be 2. Now I can write tangent 15. Tangent 15 degrees equals what I see opposite, 1 over its adjacent side, which is 2 plus root 3. Of course, we won't write it like this. We'll multiply the denominator here by its conjugate, with 2 minus root 3, so that there won't be a radical in my denominator. That's the purpose here. Let's multiply the numerator first, 2 minus root 3. Now let's multiply the denominator. Now, since this is an expression in the form of a plus b times a minus b, it can be written as a squared minus b squared. Therefore, 2 squared is 4. Minus root 3 squared is 3. So look, this part became 1. Therefore, I was able to quickly calculate tangent 15. 2 minus root 3. Now let me take the value I found here and substitute it in place of tangent 15 here. Tangent alpha equals 1 over 2 minus. A common mistake students make, not writing this in parentheses. But we need to write it in parentheses, because the minus here will affect the minus there. Sometimes even very good students can make this mistake. If you subtract 2 from 2, nothing is left. And then I'll say minus minus becomes plus, so it's plus root 3. So in short, this part became root 3. Tangent alpha is 1. After finding it as 1 over root 3, look, we have a triangle here and we can see this ratio here, right? Look, this means the ratio of what you see opposite alpha to its adjacent side. What does this ratio give us here? Look, the ratio of what you see opposite the 30 degrees here to its adjacent side is 1 over square root of 3. So from this, I understand that alpha must be 30 degrees. Now, when alpha turns out to be 30 degrees here, by the way, we've solved the question. When it turned out to be 30 degrees, I thought, could there be a geometric solution to this without using trigonometry? I fiddled with it a bit, but I couldn't find one. Maybe you can find one, and I'd be happy if you share it. Then maybe I'll share your solution here as well. See you next time.